So here you are asked to simplify this expression. All trigonometric ratios you have cosecant x times secant x minus tangent x. So how do you simplify this? It's very easy, simple. We know that cosecant of an angle x, here x is, the angle is a variable x here, same thing. So what will I write here? Cosecant, as you know that it is the reciprocal of, over here, reciprocal of sine. I'll do that. And also secant is the reciprocal of cosine. And we also know that tangent is a sine over cosine. Let me use those three things. For cosecant, it is 1 over sine, 1 over sine x times secant is a 1 over cosine x using the reciprocal trigonometric ratios minus using the quotient identity sine, tangent is a sine x over cosine x. Okay, so we used, having known that sine x is 1 over cosecant x, we used this identity, and we also used cosine x is 1 over secant, that is secant is nothing but secant x, and so secant x equal to 1 over cosine x. Similarly, the quotient ratio is tangent is sine over cosine. Okay, that's first step. And in the second step, let me multiply these two. So you just have 1 over sine x times cosine x minus sine x over cosine x. Okay, it's cosine. So now if I look at these denominators, okay, that first equal to this, then that, in the next step. Here in the first denominator is sine x times cosine x. Now the second denominator is only cosine x. But it will be easier for me if I can make those denominators same. So having the cosine already, if I multiply this by sine x, now what happens? This denominator also became sine x times cosine x. There also sine x times cosine x. Now having multiplied the denominator by sine x, so you multiply the numerator also by sine x. Whatever you do to this denominator did the same thing to the numerator, so nothing is changed. We just multiplied and divided by sine x so that our simplification will become easier. We did not change the value of anything. Okay, next, this is 1 over sine x times cosine x minus, the numerator I am seeing sine x times sine x. What is sine x times sine x? That gives me sine square x. And in the denominator we have cosine x times sine x, and that is same as this first denominator. So we have the same denominators, hence we can just write it as a common denominator over here, sine x times cosine x, and see that's two denominators are same, just write down the leftover numerators. 1 remains here minus sine square x. This is like regular simplification of numbers. Whenever you deal with fractions in the numerical form, we follow the same process, nothing different in this trigonometric functions. It is just the same. Now, in this case here, we have 1 minus sine square x, and we know that the first Pythagorean identity, what is that? We have sine square theta plus cosine square theta is equal to 1. So, we'll make use of this identity for this step. What is that we have just now? We know that sine square theta plus cosine square theta is equal to 1. So, if I move this sine square to the other side, that is subtracting sine square theta on both sides, what happens? Take away sine square theta. There also take away sine square theta to give you, cancel out, bring it down, cosine square theta. Cosine square theta is equal to 1 minus sine square theta, 1 minus sine square theta. That is, I can replace this 1 minus sine square theta by cosine square theta. That is what you got from this Pythagorean identity. So going back to this problem here now, I can replace this 1 minus sine square x as cosine square x. Just instead of theta, I have x there. 1 minus sine square x is equal to cosine square x. So I'll write it here, cosine square x. And in the denominator, I forgot x here. I have sine x times cosine x. Are we done with the simplification? No, not yet, because I am seeing a cosine x here and on the numerator also cosine x, so I can cancel off. It is just something like, if I have a square over ab, on simplification what happens? Here two a's are there. A square means a times a, so one a gone here and that a, so you are left over with a over b. That is the remaining thing. Same way here, cosine square x over cosine x, that is cosine x times cosine x. So one cosine will go off from the numerator, leaving behind only one cosine x. So cosine x over sine x. Alright. So still now looking at this cosine x over sine x, I am reminded of this quotient identity, right? Cosine theta over sine theta is equal to cotangent. Therefore, this cosine x over sine x, I can also write it as cotangent or cot x. This is the simplified form of the given expression. Okay, so this thing, cosecant x times secant x minus tan x is nothing but cotangent x. Alright, and so we made use of the reciprocal identities, quotient identities, and you ended up with this. And the simplification is like regular simplification only. So please go through it and you try to answer this problem. Simplify cosecant x minus cosine x times cotangent x. What do you get from this? Try to write it as a single trigonometric ratio. Okay, thank you. Thanks for watching.